Chapter 5, Equations of Straight Lines. Now we already know how to derive coordinates from an equation and plot those points on a Cartesian plane. In this chapter, we shall learn more on these equations of straight lines. Consider these two lines. What is the main difference between them? The obvious difference between the two lines is their inclination or slope. This slope can very well be seen from the angles these two lines make with the x-axis. Every straight line has a slope with respect to the horizontal axis. The measure of the slope is called the gradient. In the Cartesian plane, the gradient of a line is the measure of its slope or inclination to the x-axis. The gradient of a line is defined as the ratio of change in the y-coordinate or the vertical rise to the change in the x-coordinate or the horizontal distance. Therefore, gradient is equal to change in y-coordinate over change in x-coordinate, or delta y over delta x. Again, consider a line passing through the points A, x1, y1 and B, x2, y2. From point A to point B, the change in the x-coordinate or the horizontal change is x2 minus x1, and the change in the y-coordinate or the vertical rise is y2 minus y1. By definition, gradient is equal to y2 minus y1 over x2 minus x1. For example, find the gradient of a line passing through the points 2, 5 and 7, 9. In the solution, we know gradient is change in y over change in x. 9 minus 5 over 7 minus 2 gives us 4 over 5. Now, the gradient does not depend on the direction of change, but care must be taken to subtract the corresponding coordinates. Thus, also, gradient can be given as 5 minus 9 over 2 minus 7, which is equal to minus 4 over minus 5, and that gives us the same answer, 4 over 5. Let us now find the gradients of these two line segments. We start with AB. Line AB passes through the points minus 3 minus 4 and minus 1 minus 1 amongst many other points. We just pick any 2 points. Its gradient is therefore given by change in y over change in x, minus 4 minus minus 1 over minus 3 minus minus 1. That gives us minus 4 plus 1, which gives us minus 3. Minus 3 plus 1 gives us minus 2, and therefore the gradient of that line is 3 over 2. For line CD, the line passes through the points minus 3, 5 and 8, 1. Gradient is equal to change in y over change in x. 1 minus 5 over 8 minus minus 3 gives us minus 4 over 11. Notice that the gradient is always negative when the line is inclined in the direction such as CD and positive when it's inclined in the direction of AB. Now let us find the gradient of the x-axis. We pick 2 points, say 1, 0 and 4, 0. Gradient is change in y over change in x. 0 minus 0 over 4 minus 1 gives us 0 over 3, which is equal to 0. The gradient of the x-axis is 0. What of the y-axis? We pick 2 points, 0, 2 and 0, 6. Gradient is equal to 6 minus 2 over 0 minus 0, which gives us 4 over 0. When a number is divided by 0, the answer is too large, we say it's infinite, and so the gradient of the y-axis is infinite. Next, equation of a straight line. Now, the equation of a line gives the relationship between the x and y coordinates of the points that lie on that line. Consider a line passing through the points A 2, 3, B 5, 9, and C 0, -1. The gradient of the line picking points A and B is given by gradient is equal to change in y over change in x. 9 minus 3 over 5 minus 2 will give us 6 over 3, which is equal to 2. For the gradient of the line picking the points A and C, we shall have 3 minus -1 over 2 minus 0, which gives us 4 over 2, which again is equal to 2. The gradients of the line AB and AC are the same because A, B, and C lie on the same straight line. Then, a straight line has a constant gradient. Now consider a point P whose coordinates are x, y on the line AB. The gradient of AP is the same as the gradient of AB because a straight line has a constant gradient. And therefore, change in y over change in x should give us the same answer, 2. Let us work that out using x, y. Y minus 3 over x minus 2 should give us 2. Therefore, doing our cross multiplication, y minus 3 is equal to 2 times x minus 2. That gives us y is equal to 2x minus 1. This is the equation of the line passing through the points A, B, C, and P. In this case, coordinates of only 2 points are required to determine the gradient. The general point x, y enables us to find the equation of the line. And so the equation of a straight line can be determined if 1. 2 points on the line are known, or 2. Its gradient and a point are known. For example, find the equation of a straight line through the points 1, 3, and 4, 8. First, we find the gradient. Gradient is change in y over change in x. That is 8 minus 3 over 4 minus 1 will give us 5 over 3. We then take an arbitrary point x, y and any of these 2 points. So let's take 1, 3. Y minus 3 over x minus 1 we equate to the gradient 5 over 3. Cross multiplication, 3 times y minus 3 is equal to 5 times x minus 1. That gives us 3y minus 9 is equal to 5x minus 5. Then 3y is equal to 5x plus 4. You can leave it like that, but you can also simplify the left hand side to remain with y. So we divide everything by 3 and we shall have y is equal to 5 over 3x plus 4 over 3. Another example, find the equation of a line through the point 3, 4 and with a gradient of minus 1 over 3. In this case, we have a point and the gradient, so we do not need to calculate the gradient. We simply take an arbitrary point x, y. And then y minus 4 over x minus 3 we equate to the gradient minus 1 over 3. Notice that you can put the negative sign anywhere, either on the numerator or the denominator. It will not make any difference. So in our case, we put it on the numerator. Cross multiplication, 3 times y minus 4 is equal to minus 1 times x minus 3. 3y minus 12 is equal to minus x minus 1 times minus 3 is plus 3. So we get 3y is equal to minus x plus 15. Dividing everything by 3, we shall get y is equal to minus x over 3 plus 5, or y is equal to minus a third x plus 5. Let's find the equation of the x-axis. We've said that the gradient of the x-axis is 0. So we choose a point, say 3, 0, and another one, x, y. Finding the equation, y minus 0 over x minus 3 is equal to 0 over 1. Cross multiplication, y minus 0 is equal to 0, and therefore y is equal to 0. This is the equation of the x-axis. The equation of the y-axis is the reverse of this, that is x is equal to 0. Next, the general equation of a straight line. Now, consider a line whose equation is y is equal to 2x plus 3. We can obtain any 2 points on this line by taking any values of x and substituting them in the equation to get y. For example, let's take 2 values of x, minus 1 and 1. And then we substitute in this equation and we get the corresponding values of y. So when x is minus 1, y is 2 times minus 1 is minus 2 plus 3 is 1. When x is 1, y is equal to 2 times 1 plus 3 is 5. And so we have 2 points, minus 1, 1 and 1, 5. We can now plot these points on the Cartesian plane and they will give us the graph like this one. And the equation of this line is y is equal to 2x plus 3. Now, using this line, we can find the gradient. And we take any 2 points. Let us take 1, 5 and minus 1, 1. Gradient is change in y over change in x. 5 minus 1 over 1 minus minus 1 should give us 4 over 2, which is equal to 2. Another thing to note, the line cuts the y-axis at point 0, 3. This point is called the y-intercept of the line. It is important to note that the y-intercept occurs when x is 0, which is the equation of the y-axis. And so, for the line with equation y is equal to 2x plus 3, the gradient is 2 and the y-intercept is 3. Once again, consider another line whose equation is y is equal to a half x minus 2. We take 2 values of x and substitute in the equation to get the corresponding values of y. So we shall take 0 and 4. And when we substitute that, when x is 0, y is minus 2. And when x is 4, a half times 4 is 2, minus 2 is 0. And so we have 2 points, 0 minus 2 and 4, 0. When we plot them on the Cartesian plane, this is the graph we obtain. The equation of that graph is y is equal to a half x minus 2. Now, using the same 2 points on the line, we can find the gradient. 0 minus 2 and 4, 0. So gradient is change in y over change in x. 0 minus minus 2 over 4 minus 0. That is 0 plus 2 is 2, 4 minus 0 is 0. And so we get the gradient is 1 over 2. Again, the graph cuts the y-axis at a point at 0 minus 2. And so the line y is equal to a half x minus 2 has a gradient of 1 over 2 and y-intercept is minus 2. In general, The equation of a straight line is given as y is equal to mx plus c, where m is the gradient and c is the y-intercept. All equations of straight lines can be written in this form, where m and c are known. An example: determine the gradient and the y-intercept of the lines. First line, y is equal to 8x plus 1. Relating this to the general equation of a straight line, y is equal to mx plus c. M is equal to 8, so the gradient is 8. C is equal to 1, and therefore the y-intercept is 0, 1. Second line, 3y plus x is equal to 9. The first thing we do is to write the equation in the form y is equal to mx plus c. So we have 3y is equal to minus x plus 9. Dividing both sides by 3, we shall have y is equal to minus 1 over 3x plus 3. And so m is minus 1 over 3, which is the gradient. C is 3, and therefore the y-intercept is 0, 3. How about the equation y is equal to 3? Now this is the same as y is equal to 0x plus 3. The gradient is 0 and the y-intercept is 0, 3. That line is parallel to the x-axis, so it doesn't have a slope. What about y is equal to x? And this is the same as y is equal to 1x plus 0. Gradient is 1 and y-intercept is at 0, 0. Now we look at the x and y intercepts. The x and y intercepts describes the points where the straight line meets the x-axis and the y-axis respectively. Consider this line. The equation of this line is y is equal to 2 over 3x minus 4. The important thing to remember is that the equation of the y-axis is x is equal to 0. And so where the graph meets the y-axis or the y-intercept, the value of x is 0. For instance, on our line, the y-intercept is at point 0 minus 4, and you see the coordinate of x is 0. Again, the equation of the x-axis is y is equal to 0. So then, at the x-intercept, the value of y is 0. In this graph, the x-intercept is at 6, 0, and so the coordinate of y is 0 at this point. Given an equation, to find the y-intercept, we substitute x with 0. And it is easy to see that in the general equation, y is equal to mx plus c. If you substitute x with 0, then y is equal to c. It's thus no surprise that we say that c is the y-intercept. To get the x-intercept, we substitute y with 0 and solve for x. For example, find the x and y intercepts for the line 2x plus 3y is equal to 6. Now, this line has not been written in the general form y is equal to mx plus c, but it is still the equation of a straight line and can be written as such. Nevertheless, to solve for the x and y intercepts, you don't have to write it in that format. We start with the x-intercept and we substitute y with 0. So we have 2x plus 3 times 0 is equal to 6. 2x is equal to 6 and x is equal to 3. The x-intercept is at 3, 0. Y-intercept, we substitute x with 0. And so 2 times 0 plus 3y is equal to 6. 3y is equal to 6 and y is equal to 2. It means therefore that the y-intercept is at point 0, 2. Now let us look at parallel lines. Now consider two lines with equations y is equal to 2x plus 4 and another line y is equal to 2x plus 1. Now we want to draw these two lines on the Cartesian plane. So we look for any 2 points. For the first line y is equal to 2x plus 4. We pick minus 3 and 0 for x and then calculate the corresponding values of y. So when x is minus 3, y will be, that is minus 6 plus 4 is minus 2. When x is 0, y will be equal to 4. And so we have the first 2 points, minus 3, minus 2 and 0, 4. We plot those 2 points on the Cartesian plane and we have this line. And that line has the equation y is equal to 2x plus 4. For the other line, y is equal to 2x plus 1, we pick 2 points, 1 and 0. So when x is 1, y will be 3, and when x is 0, y will be 1. So we have again 2 points, 1, 3 and 0, 1. Again, we plot these 2 points on the Cartesian plane and we have this graph. And this line has the equation y is equal to 2x plus 1. Now, notice that the two lines are parallel. Also notice that both lines have the same gradient, 2. Therefore, parallel lines have the same gradient. Conversely, lines that have the same gradient are parallel. And so we say in parallel lines, gradient 1 is equal to gradient 2. For example, find the equation of a line which passes through the point 35 and is parallel to the line y is equal to minus 3x plus 1. In the solution, for the line given y is equal to 3x plus 1, gradient is equal to minus 3. And so the gradient of the other line is also minus 3. We know one point on this line, that is 3, 5. We take another arbitrary point xy and equate that to the gradient. Y minus 5 over x minus 3 is equal to minus 3 over 1. Cross multiplication, y minus 5 is equal to minus 3 times x minus 3. That gives us y minus 5 is equal to minus 3x plus 9. That will give us y is equal to minus 3x plus 14. Notice that the gradient of the second line is the same as the gradient of the first one. Another example. A line through the point minus 2, 4 and 3, 5 is parallel to the line passing through the point A6 and minus 4, 1. Find A. The gradient of line 1 with the points minus 2, 4 and 3, 5 is 5 minus 4 over 3 minus minus 2, and that gives us 1 over 5. That's gradient 1. Line 2 has the same gradient. We have points A6 and minus 4, 1. And so 1 minus 6 over minus 4 minus A is equal to 1 over 5. Minus 4 minus A is equal to 5 times 1 minus 6. That gives us minus 4 minus A is equal to 5 minus 30. Minus A is equal to minus 21 and A is 21. Lastly, perpendicular lines. Now consider two lines, y is equal to 3x minus 2 and y is equal to minus a third x plus 1. Let us plot these two lines on the same plane. We get the points first. For the first equation, y is equal to 3x minus 2. We take two values of x. I'll take 0 and 1. When x is 0, y will be minus 2. And when x is 1, y will be 3 minus 2, 1 as well. And so I have 2 points, 0, minus 2, and 1, 1. So when we plot these 2 points on the Cartesian plane, this is the line we obtain. And the equation of this line is y is equal to 3x minus 2. Next line, y is equal to minus a third x plus 1. I'll take the values of x, 0 and 3. When x is 0, y will be 1. When x is 3, y will be 0. And again, I have 2 points, 0, 1 and 3, 0. And again, when I plot these 2 points, this is the line I obtain. And the equation of this is y is equal to minus a third x plus 1. We notice that the two lines meet perpendicular to each other. Also, there is something about their gradients. The gradient of line 1 is 3 and that of line 2 is minus 1 over 3. In general, if two lines are perpendicular to each other, the product of their gradients is minus 1. For example, find the equation of a line through 0, 3 and is perpendicular to another line with the equation 2x plus 3y is equal to 4. The solution: first, we write the equation of line 1 in the form of y is equal to mx plus c. 2x plus 3y is equal to 4. 3y is equal to minus 2x plus 4. We divide both sides by 3. And so gradient 1 is equal to minus 2 over 3. For perpendicular lines, gradient 1 times gradient 2 is equal to minus 1. And so gradient 2 must be equal to 3 over 2. Because minus 2 over 3 times 3 over 2 will give us minus 1. Now we know the gradient of the second line and we have 1 point, 0, 3. So let's get its equation. Get another arbitrary point xy. And we have y minus 3 over x minus 0 is equal to 3 over 2. Cross multiplication, 2 times y minus 3 is equal to 3 times x minus 0. 2y minus 6 is equal to 3x minus 0. 2y is equal to 3x plus 6 and y is equal to 3 over 2x plus 3. Someone may ask you to find the coordinates of the point of intersection of these two perpendicular lines. In such cases, you get the two equations and solve them as simultaneous linear equations.
The way we teach it in university and in high school as well, in colleges, is if you fall behind, you're in desperate trouble. That if you miss a class or miss an idea or don't do your homework, you go to the next class and the teacher assumes you know it, but it's like Greek to you. And so the biggest challenge is not falling behind, and the strategy is do whatever needs to be done so you don't fall behind. Seek help wherever you can find it, from students, from student help centers, from the teacher, from the teaching assistant, wherever you can get it. Because if you fall behind, it's like you're missing a floor in the building, you're missing a brick in the wall, and you just can't build the second floor without a good understanding of the first floor. It applies course to course, it applies class to class. Miss a class, one class, maybe that's fine. Miss 2 or 3 for whatever reason, the rest of they're speaking a foreign language for you, and you just have to make it up, or going to class has no point. If you don't go to class, it just gets worse. It snowballs, and once it starts going downhill, you're in trouble. And so the biggest secret or the biggest piece of advice is get help early from as many people. And there's lots of sources for help, that other students in the course, teachers, etc. And so go there for it, and go early and go as often as necessary.